Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will calculate the area of triangles. Now, you're used to calculating the area of a triangle using half base times height. But that formula requires the perpendicular height. Sometimes you just don't know the perpendicular height. What if we have a triangle like this? So I'm just going to label the sides. So let's call this side C, B, and A. So remember, angle A is opposite side A, angle B opposite side B, and angle C opposite side C. So what we can do, if we know two sides and the angle between, we can calculate its area using this formula here, half AB sine C. So it's actually really easy to do. We just go half times this times sine of this. This allows us to find the area of a triangle when we don't know its perpendicular height. Calculating the perpendicular height might not always be easy. So let's look at an example. So let's say I want to calculate the area of this triangle here. I don't know its perpendicular height, but I can just calculate its area as half times A times B times sine of the angle in between. And if you put that in your calculator, you should get an answer of 30, and it'll just be units squared because we're not told the units. It's really as simple as that. Of course, it doesn't matter which side you call A and which you call B, as long as it half times a side times sine of the angle in between. So that's really all there is to it. I'm just going to do a quick example where we need to do a bit of extra work before we can use the formula. So let's say I want to find the area of this triangle here. Well, I can't use half times base times height because I don't know the perpendicular height. So I want to use half AB sine C. The problem is I have A and B, but I don't have C, the angle between. It isn't half times 11 times 8 times sine 20, because sine 20-degree angle is not in between these. So if I want to use half AB sine C, I'm going to need to find this angle here. So that's not going to be an easy thing to do. So it's not really easy to find X just as it is, but because I have a side and its opposite angle, and this side here, I could find this angle here using the sine rule. If I find this angle here using the sine rule, it's easy to find this one. It'll just be 180 minus 20 minus that one. So let's do that. Let's find y using the sine rule. So let's find y using the sine rule. So because y is an angle here, remember when we're finding angles, angles go on top. Sine of y over its corresponding side is equal to sine of 20 over its corresponding side. So again, we times each side by 8 and then take the sine inverse. So y will be the sine inverse of 8 times sine 20 over 11. So if we put that on our calculator, we get an answer of about 14.4 degrees. I'll just round it to one decimal place. So remember, when finding angles, unfortunately, we need to check the ambiguous case. So the other possible solution for y would be 180 minus 14.4. But that would give me an answer of 165.6. This angle here can't be 165 because then we'd have 165 plus 20 is more than 180. So this is one of those cases where the second solution is not a possible solution. The only answer here is y is 14.4 degrees. So there's only one possible value for y. That means there's only one possible value for x. X is just going to be 180 minus 20 minus 14.4. So that leaves us with 145.6. So 145.6 degrees is this angle here. Now I have a side, and the angle between them. So I can easily calculate the area. The area of this triangle will just be a half AB times sine of c. Well, I know I said x, but it doesn't matter what I call it. Half times side times sine of the angle between them. So we'll just put that in our calculator, making sure it's in degrees mode. So to 2 decimal places, we get the answer about 24.86. Of course, the sides were in centimetres, so the area is centimetres squared. And then we're done. This part of the calculation, half AB sine C, is easy. Just sometimes you might have to do some work so you have enough information to use the formula. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.